Hello, welcome and good evening to another episode of Let's Code MS-DOS. This is the 16th episode, so yay! We are breaking into the second digit of our hex code counter. And last time we learned how to program the copper bars in VGA text mode. The same works, of course, also for the graphics mode. There's not much difference there. And I think this is already a very neat effect of the VGA card, but the VGA card can actually do so much more. And today we want to look at another nice effect that is actually pretty cool, and I wonder why not more programs used it, because it's actually pretty neat. And we'll be doing this in text mode again, and in graphics mode it will be similar, and we will come back to that once we'll cover more of the 256 color VGA modes. But for now we will stay in text mode because it's actually pretty impressive. We'll be doing smooth scrolling, vertical scrolling here, but horizontal scrolling is possible as well, but that's for a later episode. But vertical smooth scrolling, and this looks pretty impressive because usually in text mode you can scroll, yes, that's not a big problem, but you scroll line by line, and this looks very jumpy. And since you can't address pixels individually in text mode, it's actually pretty impressive that you can do some kind of smooth scrolling in VGA. And we will start off with a version of the copper VGA program from last time, but we will change a few things, right? So first of all, I will change the sign function. We pre-computed a sign function, and this time we want to scroll the screen by one page, and one page in text mode is 400 lines of pixels. So I want to have something like 400 here as the value that we're scaling to, instead of 256, and I need higher resolution for the sign table as well. So that's why I put already a 512 here, and I will also make the array 512 bytes long so that we can have very, very smooth sign function with almost pixel accuracy. And we need to change the normalization factor here as well to 511 instead of 255, because now the sign function will go from 0 to 511 in the y direction. And we will have, am I talking crap? Yes, sort of. So in the x direction, so the input parameters will be 0 to 511, and the y direction will be 0 to 400. Okay, that's nice. We will still do the initialization, we will do our main loop, and that's more or less it right now. Then getting the character so we don't get a spurious return or something, return key when we exit, and restoring the text mode, of course. That's all good and fine. But how does the vertical scrolling actually work? Well, if you take a look at the documentation for the CRT controller registers, there are two things. There are two registers, 0C hex and 0D hex, for the start and address high and low. And if you take a look at that, it says this contains the bits of the start address field. The upper 8 bits are specified by start address high register, okay. The start address field specifies the display memory address of the upper left pixel or character of the screen. Okay, this sounds pretty nice, doesn't it? Normally this field is programmed to 0 except when using virtual resolutions, paging and or split screen operations. And paging means scrolling basically, because if you increment this by the number of pixels per line, you get line accurate scrolling, at least in graphics mode, but not in text mode. It will scroll for a whole screen basically. So we will do that. We'll do that right here. We will do something like this. We will need to write to the right register. So we will output a byte to the CRTC index register. and we will call it start register high. That's where we're writing to, and then we will do CRTC data, and we will need to write a byte there, so we do a cast, although I don't think it's strictly necessary. And what will we write? Well, some kind of offset, but the offset shifted 8 bits to the right, because we are writing out the high byte, basically. So we are now missing a few things. The offset is equal to whatever line we are in currently with the scrolling, times 80. Why times 80? Because we have 80 characters per line. So you always have to calculate the offset number of pixels or characters in text mode times the width of the screen. And the width of the screen can actually be adjusted, but that's also something for later. So the VGA is pretty flexible here. Okay, so we need to introduce a variable, offset. Let's call it, I think we should use an unsigned in here to make sure this is all good. And we will have also an unsigned int line, and that will be 0 in the beginning at least. Okay, so there we have that. Then we will need to do our regular syncing to the vertical retrace. You already know the drill, disable and enable the interrupts. Then do an output, no, wrong, do an import, while import of the input status register of the VGA, mask with vertical retrace bit, wait for the current picture to finish, the current retrace to finish, if there's any, and then wait for the picture to finish and close some parentheses, and we should be good. Okay, we have to do the output on the CRTC first, because the start register is only evaluated once per screen refresh, I think, if that's correct. And if we do it after that, we will get some jumpy, jittery stuff, so that will look pretty bad actually. Start register low is also fine, and here we are just doing masking with the low byte. Okay, that should actually set everything. This will do line-wise scrolling if we now do something. And what is it that we want to do? Well, we have to have a frame counter or something. We will increment that, and we will also introduce that here. Let's do frame equals 0 here as well. And then we can actually calculate the line value, right? So we will have to calculate a y-coordinate, and this will be our sine function indexed by the frame modulo 512, because we have 512 values in there, and then after that it repeats. And the line is basically just the y value divided by 16, because every character on the VGA card is 16 pixels high. So then we get a wavy scrolling effect with 16 steps. And this is actually it, but I probably forgot a couple of things. There are errors. Okay, we need to define the start register, and we saw that here. So the start address register and the are 0C and 0D. So define start register high 0x0C, and then copy that, and 0x0D is the next, and we didn't define y. That's also bad. Let's put it here as well. Y equals 0. Build everything. And we still have something. Oh yeah, I should have been low. And if we run that, not much happens because we did an oopsie. All right, that's embarrassing. And I think on the Mac I can't break. No, I don't have a break key. That's too bad. Okay, so we quit and we restart DOSBox. That's the good thing about DOSBox. It's easy to restart. So what did we do wrong? We coded an infinite loop, it seems, right? But which one? Disable, enable. That's fine. While not keyboard hit, that's also fine. I could just imagine that we did something wrong here. Oh yeah. Who spotted it first? Total stupidity. Total stupidity, yeah. Masking is a bit like that. Doesn't make sense at all. So we got stuck in the while loop and everything broke. Okay, now this is not nice to look at. Oh my god. Terrible. But okay. Now I'm wondering if that's actually supposed to look like that. Probably not. But the rest is, I think, fine. The sign function should be okay. Tell you what, so that we see actually something nice, let me introduce you to something. There's a program called the Draw. And the Draw is a paint program for text mode. So you can basically choose some colors. I'm selecting background color. Yeah, let's take blue as a background. Did it use that? Actually choose that? I don't know. And you can draw with ASCII characters, choose different styles, and do all kinds of things. So I created a little something. I'm not a good artist, but I did this and a second page as a means to fill the frame buffer in the text mode. And what you can actually do is you can actually save in C, that's here, as a C header file, and include that into your program, which is pretty neat. And that's what I did. So we can actually go back to our program and load our C program. And if we look in the directory, I have two files here called root42.1 and root42.2.h, and they define the whole frame buffer here. And you can simply include that file and poke the image data here into video memory. So let's do that so that we can see actually a bit more what's going on and maybe get sick a bit more by the weird scrolling. So what we need to do is to include those files, include, and now with the quotation marks because we are including from the local directory, root42.1.h and root42.2.h. And I named, you can actually pick a name for those things, and the picture number 1 is called image data 1, and the picture number 2 is image data 2. So that's nice that you can name that. So we need to define the frame buffer, and again it's an unsigned character pointer, but it's a far pointer because it includes the segment. We call it buff for buffer, and it's actually it's segment B800 for the text mode, and offset 0. So to write that in C notation, it will be just like this. Pretty neat, huh? Okay, so after initializing our sine function, we will put everything into the memory. And we already know that the whole thing has length image data 1 length, because that's defined, so we don't need to calculate anything. And we will poke that by just doing buff ++ equals image data 1 of I. Isn't that simple? And the same thing can be done with image data 2, and it will just write to the second video page. And of course we need now also a variable I. We have one warning, non-portable pointer assignment. Okay, yeah, we need to cast that, because this is not a pointer for C. So we need to tell C, yeah, this is an unsigned character far pointer, very explicitly, and then the warnings are silent. But it looks weird, so we did something wrong. And I think we might have screwed up our computation here. And I'm wondering why. Let's double check the register. So I said register high would be 0x0c, that's correct, and 0x0d is also correct. That's fine. Am I writing correctly? So let's think about that as well. Start register high. Then what I did earlier was to explicitly mask out the high bit only. But that actually shouldn't make any difference, in my opinion. So let's check that. No, exactly. So this doesn't matter. But something else is wrong. Who can tell me what is wrong? The vertical retrace should be fine. I think this here is wrong. I need to do it like this because and has a pretty low precedence. I think it was, yeah, now we are talking. So that was the problem. It was not synced to the vertical refresh. And now this looks already nice, right? Has a nice DOS logo there and a red blob. And it's scrolling with a sine pattern. That's neat. But now we'll make it smooth actually. And how do we do that? Well, for that, let's look at the documentation. And looking through the documentation, you will find the preset row scan address register. No, preset row scan register. That has index 8. And two things can be done here. The byte panning is not interesting for us right now, but the preset row scan is nice. Basically what this allows is to shift the start line of what is being rendered by up to 31 lines, because it has 5 bits. We'll only need 4 because we need to scroll 16 at most, but this is exactly the register that we're interested in. So let's define it before we forget it again, and let's put it here. So define preset row scan as 0x08, and then we simply copy this because it will be similar. CRTC index and preset row scan. And this is for pixel accurate scrolling. So we will output the value, we call it pixel, I would say. Pixel sounds good. And to make sure that we don't write any garbage, we will mask it to the lower 4 or 5 bits. So 0xF should do the trick. Then of course we need to compute the pixel value, and this is basically just the remainder of our division here, so y modulo 16. In the beginning it will be 0 pixels, then 1, 2, 3, 4, 5, etc. up to 15, and then when we switch to 16 we'll jump back to the 0th pixel and the next line. Well, that's pretty straightforward, right? And to make sure that we have a nice thing here, we'll initialize it with 0, and we'll just use a byte for that. So, do we have to do anything else? I don't think so. Let's see if it works, and then we go through the code once more. No warnings. But also it doesn't work. So we did something wrong. What did we do wrong? Where did we go wrong? Oh yes! Copy and paste error as usual. CRTC index twice. The next byte should go to CRTC data, obviously. First write to the index register, then to the data register. And it works. Have a look at this. So this is pure text mode. And I will again show you the same thing on the 386 on a real machine, so that you see that it's not only DOSBox doing this, but it's extremely smooth. It's even better in person because I can only render to 30 frames per second, and on a real machine this again will be 70 frames per second, and that's incredibly smooth. So as you can see, it's a really neat thing, and it's really small. What did we learn today? We learned about the start register, high and low address, the preset row scan address register, and it was simple enough. Just set the start address first, wait for the retrace, and then set the preset row scan. Okay, so here we are on the 386 and running Turbo C, loading our program. And yeah, it's the same basically that you had before. I cleaned it up a bit, and this is also the version that I will upload to GitHub, link in the video description, so you can check out the code. And then let's run it, and as you can see, it works also on a real machine, captured via the OSSC and my HDMI capture device, and it looks smooth as butter. I like it. So where can we build on that? We can put in horizontal scrolling, that will be an upcoming video. We can use it also in graphics mode, that will also happen later. But for now, that's it for today. I hope you liked the video. Please consider subscribing, and if you want to drop a coin in the hat, feel free to go over to Patreon or to Ko-fi. No commitment. If you don't want to, just leave it be. Leave a comment. And otherwise, I hope I will see you next time, and so long. Bye.